Bismillahirrahmanirrahim. I wanted to do two examples to complete this particular section of parallel lines and transversals. So here's a question that I got from your textbook. So here we have a quadrilateral type of shape, and we are told to basically find the value of x and y. So here's x and here's y, where the instructions are to solve for x and y. And, well, you have to be careful here because we're told that this line and this line are parallel. Now, and then in these type of questions, it's actually very, very important to make sure we are aware of which lines are parallel, which lines are not parallel, which lines are transversal, because if you make that mistake, you can make these two to be like corresponding consecutive interior angles or something like that, which is actually not the case. So you have to be careful to make sure you pay attention to which lines are parallel and which affects the angles that they create. So that's we know that these two lines are parallel. Now, these are segments, really, of course, right? Because they're not lines per se, but segments form part of lines. So you can kind of like extrapolate these. You can say if these segments are parallel, then there's a line here that's parallel, and there's a line here that's parallel like that, right? So that's how you can think about these. Those two lines are parallel, and they are part of this particular quadrilateral. So you can, in your mind's imagination, you work with the question like this. And then the other two lines, in fact, are going to be transversal. So you can extrapolate this line here like this. That's a transversal, and that's the first transversal like this. Maybe I should just draw it out, shouldn't we? So maybe here's a first transversal, right? And then here's another transversal here that crosses these two lines. So if I could just draw it maybe reasonably accurate. So these are parallel lines, and this is one transversal, and then another transversal crossing the same parallel lines. Okay, so there we have it. That's the setup for the question. So let's solve for x and y. Now, how do we solve for x over here? Well, if two lines are cut by a transversal, now here's a parallel line and here's a parallel line, and the transversal that's cutting those two parallel lines is this one over here. So that's what we're going to use. So if two lines are cut by a transversal, then this angle and this angle, now it's kind of like this. See, that's one parallel line. Those are two parallel lines, and that's the transversal over there. So the transversal is going like this, and that's 2x here, and that's 96 degrees over here. So then you can see that these are consecutive interior angles, right? So those two angles are consecutive interior angles. So 96 and 2x, those are consecutive interior angle for these two parallel lines. So what do we know about consecutive interior angles? That they add up to 180 degrees. They are supplementary. So you have 2x plus 96 degrees equals to 180 degrees. So that's an equation that we can set up, and all we have to do now is just solve for x. So subtract 96 from both sides like this. So that's 2x. So 2x is going to be equal to 90 minus 2. That's 84, right? So 84, that's 84. So and then you divide by 2. I hope that my math is correct because it's kind of late at night. So 84 divided by 2, that's going to be 42 here. So x is going to be 42. So we are asked to solve for x. That's easy enough. And that sounds pretty good to me. So we're done for the x. Now to solve for y, then we have the same thing over here going, because now we have this parallel line, and that's the transversal. And then as you can see again that these two are going to be supplementary, almost pretty much identical problem here, really, right? So we have 3y plus 44, that's that particular angle, plus 94 is going to equal to 180 degrees. So that 3y plus, I can add these together here, I guess. So let me just reduce over here. 94 plus 44, that's 8. That's 138, right? So that's 138 is equal to 180 degrees. Now I can subtract the 138 from both sides like this. And I hope you better check my math over here. So 3y is going to equal to That's going to be 42 over here, I believe. And then I just have to divide both sides by 3, like this, to solve for y. 3 divided by 3 is 1 last time I checked. So this is going to be 3 goes in there 1 time, then 3 goes there 4 times 3 is 12. So y is going to be 14, and ta-da, there we have it. So this questions and questions like this are tricky only because you have to be careful to make sure that you got the right parallel lines or right transversals, and not to confuse the transversals with the parallel lines and the parallel lines with the transversals. All right, I'd like to do one more question here, and here it is. So the question here is over here like this, and we're asked to solve for x. So here's x, and we're given here that these are parallel lines. The parallel lines are over here. That line is parallel to this line, and this is something funky going on over here. This ray over here and another ray, and that's creating this angle, which is like 72 degrees. Now we're asked to find x. Now how are we going to do that? Now this is a tricky one because let's see, if you maybe we can, okay, well, this is like, you can say that's vertical angles. Okay, where do we go from there? And then you can say, well, maybe this is the alternate interior. No, that's not alternate interior, because this line is going like this. If this was a transversal, it would have to continue that way. Okay, then, okay, maybe, well, if this is 50 degrees, and okay, then alternate interior, if I were to extrapolate this line, see, if I were to extend this line like this, and okay, then I could say, okay, that's 50 degrees. Then if I were to extend that line over there like this, then these are alternate interior, that's 50 degrees, and okay, that's kind of getting complicated. Maybe that would work, actually. That would work if you were to do that, because if you extrapolate this, then these are supplementary, and these are 50, you can add that, and it's a triangle, you can get this. But there's another way of doing this particular problem, and this is a kind of elegant and cute problem, and it's like this. It's a popular problem, actually. So what you do here is you draw another parallel line, right? So because nobody said you can't draw another parallel line like this. So that's what we're going to do. So I'm going to draw here another parallel line, kind of going through smack over there. It's kind of not looking parallel. I'm trying here, okay? So this is let's do it this way. I could probably have better luck this way. Here we go. I drew another third parallel line. This line that I drew, in fact, is actually parallel to the other two lines that I have created, okay? This line that I create is parallel to the other two lines. So you must understand that there's a point here, and I can make a parallel line to that point. And nobody said, there's no law against that. I could make another line over here like this, right? You know what I'm saying? So anyway, so I did that. I made that parallel line over there. Now I have 3 parallel lines. Okay, so what do you say to that? Well, then, okay, fine. I got 3 parallel lines. Well, if this is 50 degrees, then this is 50 degrees. Those are vertical angles. If that's 50 degrees, then this angle over here, because of this parallel line, the new brown one that I created, that's alternate interior angles. That's 50 degrees. Okay, so what do you do with that? Well, if that's 50 degrees, then this leftover angle, leftover from 72 degrees, because the whole thing is 72 degrees, and if I take away 50 degrees from that, and that's 72 minus 50, that's 22 degrees over there. Okay, let me do it slowly for you. Here we go. So I have 50 degrees over here, and I created a new angle, so I'm going to do it slowly, okay? 50 degrees over here. All right, then I can do alternate interior angle from here to here, right? So, but that's this alternate interior angle is going to be that part of it, right? You know what I'm saying? So that's alternate interior angle. This is going to be 50 degrees because alternate interior angle is congruent. Then I'm going to have a leftover angle over here from 72 degrees. That's this angle. So 72 minus the 50 degrees will give this little leftover angle. That's going to be 22 degrees. And that 22 degrees right here, okay, that 22 degrees, if you look at this white parallel line, and then you look at this brown parallel line, right, and then you have this other white line going like this. Let me get that white line over here going like this. What? That's not a white line. Okay, this white line over here like this, and that's the green 22 degrees over here, right? So, well, this angle and this angle are corresponding angle, and that's x over there. So this angle over here that you see, the 22 degrees angle over here, is a corresponding angle with x. So the x therefore has to be 22 degrees. That's a very beautiful, cute question. I think a popular question sometimes in tests, etc. So what did we do over here? Well, we were given a problem like this, and we were kind of creative in solving it. And we said, well, let's draw another line, and we drew this line that was parallel to the other two lines that were already drawn. And then we said, well, that's alternate interior angle, and then that's those are vertical angles, they're congruent, and the alternate interior angles are congruent. From there we got the 22 degrees, which is subtracted from 72 minus 50, and then that's corresponding to x. The corresponding angles are congruent according to corresponding angle postulate. Until next time, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.